Okay, to find the rest of the 5-number summary for this distribution, what we need to do is, of course, find all those percentiles using Dr. Stevens' method. So here, to find the 25th percentile, or Q1, because there's 20 numbers here, right? We're going to do 0.25 times 20, which is what, 5. And so using his trick, since this is an integer, a whole number, we have to average the 5th and the 6th number to get the lower quartile. So let's see. I see that there's 6 numbers after we get added in the first 2 bins. So the 5th and 6th number, and there's only 3 in the first bin. So that tells me both the 5th number and the 6th number we're estimating to be 59. So the average of 59 and 59, of course, is 59. So that's Q1. We already know that the median we just did. I did in the forum, the discussion forum, and we said that was the average of what, the 10th and the 11th, 10th plus the 11th number, average them, and those are both 80, weren't they? Yes. So that was 80 was the median. Of course, we know the minimum is in the lowest bin, so we estimated that at 52. And sorry, I labeled this as Q3. This should be Q1. Then Q3 will be 0.75, so the 75th percentile, 0.75 times 20, of course, is 15. So again, we get to average the 15th and the 16th number. And those, I believe, let's see, where do they fall? So the 15th number is 80, we're estimating. So the 16th is 87. So we're going to average 80 plus 87 divided by 2. I think that's 83.5. Okay. And then, of course, then the max piece of 100. Why would we do this? We know the maximum number we're estimated to be 87. Okay. So that's the rest of the 5-number summary. Now, we could do, it's always good to talk about the shape of this distribution. So why don't I use my spreadsheet here to create a graph? I think it will. It won't be the prettiest graph, but I think I can do it. Let's see. I want to use the midpoints and the frequencies. Let's see. It's been a while since I've done this. Insert. I was tempted to do a box plot since I already got the 5-number summary. Let's try this and see. And we're going to insert a chart. Let's see if it's smart enough to pick up what I want without having to tweak it too much. Now, I don't want a line graph. What's this? A column chart? Does that give it to me? Oh, that actually looks pretty good. Now, technically, I have a continuous distribution here because I remember we had those ranges, but since I'm labeling with midpoints, this is a histogram rather than a bar chart, right? So yeah, I would say, looking at this, I would say it's a left skewed distribution, right? Tail to the left. There's a dip in the middle. It's not perfect, which is a great time to talk about the mean. Now, I don't remember what the mean is, and I want to keep this video generic. So I'm going to stop the video for a minute and calculate the mean right here. And that'll help me with the rest of the values anyways, to have that here. So I see when I calculate the mean, it is smaller than the median. So that supports my left skewed decision, right? In a left skewed distribution, we expect those low extreme values. We expect all these 52s and the 59s to pull that mean down away from the median because they're kind of extreme values. And remember, I kind of lost my graph here. Is it here? No, I never inserted it. So you saw it. You can back up the video and see that. So yeah, so this is the left skew distribution. Something I'm going to ask you on exam 1 part 2 is look at the shape. Compare the mean and the median and make sure it checks with your decision. And I think it's left skewed and the mean position, the mean here, let me get a pointer. You can't see my hands. I expect the mean is less than the median. So yeah, that supports the left skewed distribution. We expect to see that. So with that said, we should use the median and the 5-number summary or the IQR to talk about center and spread. Just, check for outliers and all that. Okay, so keep that in mind as you do exam part 2. You won't be having a frequency table. You'll make a frequency table, but you'll have the raw numbers because you won't have to do this estimation thing. Let's see, what else are I going to do? Oh, I asked you to do a graph, talk about the shape. I want you to find the mean and the 5-number mean and standard deviation and the 5-number summary. So the only thing I haven't walked through in this video is how to find the standard deviation. So let me clear off my median work. And what you want to remember, let's take a step back. And in chapter 2, we learned to find the standard deviation for a sample. Is you take each value, whoops, sorry, not X bar. You take each value, subtract the mean from it, and we're going to divide it by n minus, and then we square each of those differences. We add them all up. We divide by 1 less than the number of numbers, and then we take the square root. And now there are all kinds of calculators on there that'll do a weighted mean and find all the summary statistics for you. It's good. I think it's good to know where it comes from. I'll never make you do that by hand, but here's how you do it by hand. Okay, and I've done this before. Let's see. I don't want to lose that 73.5. So I'm right down here. I'm going to rewrite 73.35 so that when I delete these numbers, okay, here. All right, so the first step in the process is to take each value, subtract the mean from it. So for me as a human, x minus the mean, so I'm gonna do equals. Now that my x's are those estimated midpoints, right? And I'm gonna subtract 73.35. And of course, Google Sheets is so smart, it fills it down for me. Then I have to square each of those values. Look at the formula. So x minus the mean squared. So equals, and I'm just going to click on that difference and caret 2, right? Raised to the second power. Caret, in case you're wondering, just shift 6 gets the rate exponentiation. And of course, again, Google is so smart. Now the formula says add them up. If your spreadsheet's not doing this and you just have the 455, go to the put your cursor on that little box, and then you can drag it down. Okay, and it'll automatically, it does the same thing. See what it does is it takes that value in that cell and square it. So, and then I got to add all those up. The formula says add those all up. So I'm going to find the sum of all those. So equals SUM. And see, this time it isn't understanding what I want. So I have to select those cells. So I clicked on the 455 and selected all those, right? And that's the sum. And here, let me drag this out of the way. Whoops. Control X, Control V. So now we're going to get the variance. So the variance is what we get before we take the square root. And to get the variance, we have to take that sum of all the square differences, this 946 number, and divide it by 1 less than the number of numbers. And one thing that people do, they'll see, oh, 6 bins, we're going to divide by 5. We got 20 numbers here, so we're going to divide by 19. So I'm gonna do equals. I'm gonna click on that sum divided by 19. And that's our variance. And then we're gonna take to get the standard deviation, we take the square root. On a spreadsheet, we do equals SQRT to abbreviate for square root, right? And I'll click on that square root, that variance number, and that's our standard deviation. Okay, of course, we don't use mean and standard deviation on this because this is a skewed distribution. I don't think I did anything else. I need to do anything else. So, all right, I guess that's it for this video.